5TONIC has tested automated end-to-end network slicing in 5G standalone, including dynamic radio resource partitioning, achieving, in a first phase, fully automated end-to-end network slicing based on 5G SA. Within the LIME program, and together with our partner Ericsson, we have built a proof of concept to validate the key technical aspects of the network slicing technology in 5G standalone networks. Additionally, we have executed different real use cases with interest for the industry, letting us show the value of the technology for our customers. At 5TONIC Lab, which aims to be an open global environment placed in Madrid, where members from industry and academia can work together on research and innovation projects related to 5G, we have built a mono-vendor 5G standalone network by integrating the 5G radio access and the 5G standalone core from Ericsson. Over this testbed, we have demonstrated fundamental concepts for the operation as the automated lifestyle management of a network slice and the validation of key technical aspects of this technology. We have also incorporated and tested several commercial 5G SA smartphones and CPEs with network slicing support. Over this network, we have automatically deployed 2 network slices. One of them, called the Enterprise Slice, will be onboarding the use cases that will be explained in the following sections. The other one, called the Internet Slice, will be simulating the internet access for the mass market. This scenario intends to stimulate the real situation where we will have different logical 5G networks deployed over a common infrastructure. In this case, the RAN and the 5G core control plane will be shared by both slices, while we will have dedicated user plane functions, UPFs, from the 5G core to each one of the network slices. This use case consists on a 360 video in movement production in real time, and it has been implemented with our partner YBVR. In this case, we have a 360 video camera connected to the Enterprise Slice, transmitting the 360 video content in movement and in real time, simulating the media coverage of a sport event. Additionally, we have virtual reality glasses and a set of 5G SA smartphones playing the 360 video content produced in real time. One of the smartphones is connected to the Enterprise Slice, so is able to play the content properly and with guarantees, and the other one is connected to the Internet Slice. We can see that, without congestion in the network, both smartphones connected to the Enterprise Slice and to the Internet Slice can play the video smoothly in real time and fluently. When saturating the network and without applying the proper radio resources guarantees for the Enterprise Slice, both smartphones start to experiment degradation and video stall situations in the video reproduction. Nevertheless, when activating the radio resources guarantees for the Enterprise Slice, the smartphones connected to the Enterprise Slice are able to play the video content in real time, fluently and without stalling, while the smartphones connected to the Internet Slice are not. In this case, we demonstrate that the network slicing guarantees the success of the use case even in congestion situations. For this use case, implemented together with our partner Fivecomm, we have an industrial operator guiding with his gestures remotely an autonomous guided vehicle in real time. An AGV is an industrial vehicle able to transport hundreds of kilograms at high speeds, and this is why the latency is so critical, not only to guarantee the viability of the use case, but also to guarantee the security of the employees. For security reasons, in this demonstration, the AGV is configured to move really slowly. To do so, a webcam is capturing the gestures from the operator in a video that is sent to be processed at the edge, where the proper orders are identified and sent back to the AGV. Additionally, to validate the E2E latency, the processed video with the captured gestures is sent back to the operator screen. In this case, we can see that when the mass market slice congests the network without applying the proper radio resources guarantees to the Enterprise Slice, the use case cannot be executed because the latency of the AGV executing the operator's orders is reduced reaching several seconds. Nevertheless, when applying the proper radio resources guarantees to the enterprise slice, the use case can be executed in real time, even with the network fully congested. This demonstrates that the viability of the use case relies on a technology like network slicing. With these proofs of concept, we demonstrate the viability of the use cases thanks to the network slicing technology, becoming a key enabler for the development of new services requiring network guarantees in shared infrastructures. We all know by now that network slicing allows to manage a 5G network by splitting it in pieces or slices, being each piece a network itself, independent and with specific characteristics applicable only to that slice. The details on the required architecture to deploy a slice have also been defined and tested under the scope of Project Lime at Telefonica. Then, the possible use cases and applications of network slicing are the next step. Until now, we have seen slicing at industry level by controlling robots in a factory, or slicing at consumer level by producing and consuming 360-degree high-quality video using the customer's mobile device. Thus, it is left to show a use case or service for small, medium or large companies. Therefore, we are showing now the slicing at enterprise level or enterprise slicing. Kickoff for this example is the enterprise device the employee has been given, in which a work profile is defined. When in this profile, the user would only be able to execute specific applications previously agreed at corporate level based on its utility, need and security for that company. This work profile is going to use the enterprise slice already deployed in the operator's 5G network. In the images, several but similar configurations for this profile can be seen depending on the brand and model of Android device in use. In order of appearance, we have used a Xiaomi 12, an Alcatel TCL 30 5G, a Samsung Galaxy S22, a Samsung Galaxy S22 Ultra, and a Google Pixel 6. Once created, let us see what this work profile can do. As mentioned before, this work profile uses the enterprise slice, where some rules or requirements have been defined that will condition the device behavior in this specific slice. For example, there is no internet access in this slice. Therefore, only a corporate server can be reached from the browser, showing its preloaded content, pictures in this case. The content of this server and the server itself can only be reached from the device applications using this work profile. And when an employee tries to surf the internet, he or she gets either a timeout error or the device remains thinking. On no device is it possible to access the internet. Nevertheless, it is possible to easily access the high-quality landscape pictures from the corporate server very quickly, as this traffic is prioritized in this slice. On the other hand, we should not forget the other predefined profile, the personal profile. This profile uses the second slice offered by the network, internet slice, which is more generic and grants access to the internet as its own name shows. In this profile, all the other preloaded applications the employee had in the device have been included. Device behavior in this personal profile is the usual or expected one, allowing to surf the internet, search for an app, install and execute it without issues, or open any of the other available applications in the mobile phone and use it normally. The only thing that is not allowed under this profile is to access the corporate server shown before. This is the end of this new use case that shows how a company might improve the protection of its assets just by ensuring its enterprise devices access to corporate information only through a reliable and secure channel, such as a dedicated 5G slice that limits the device's functionality while in use. It is important to notice that in both parts of this demo, the same devices have been used. The devices described before and its order has been kept too to ease its identification. It is also worth to mention that those devices are commercial samples running Android 12, also known as Android S, which is the code issued in October 2021, being the first in introducing commercially the enterprise slice concept as clear use case to offer network slicing services in 5G networks. In Android 13 or Android T, Google, Android's mother company, has expanded slicing capabilities, allowing up to 5 enterprise slices to be supported in the same device, as well as 2 consumer slices or final user slices since August 2022, showing a clear bet for network slicing and the wide variety of options it offers.